Hello, and thank you for joining today's session, Unbox, Activate, and Get Data, IoT Made Easy from FreeWave and ModuSense. Today we'll be exploring the different ways the versatile solutions from FreeWave and ModuSense make it easy to add drop-in devices for data collection and analysis. As some of you may know, we engaged in a joint venture with ModuSense in 2021, designed to bring you new solutions for customer problems. Today's discussion will help bring you up to speed with what's available and how to leverage these solutions in your networks. So a few things before we begin. This session is being recorded and will be available later on our website, as well as each of the attendees will receive an email with a link to the recorded session. Your line is muted throughout the entire session, and we will have a Q&A at the end of the presentation, so feel free to submit questions as we move through the slides via the question panel on your screen. Our hosts today are Bruce Trevarthen, the CEO of ModuSense, and Tony Battaglia, the head of global sales for FreeWave. I'm Sue Moore, and I'm the director of marketing for FreeWave. So Bruce, I'll hand it over to you.
Hello, everybody. Bruce Trevarthen, and thanks very much for the intro. So look, today we're going to cover off a couple of use cases and product options relating to the portfolio as it stands in relation to devices that can be dropped in. You know, the key point here is that these are ready to deploy solutions that you can simply take out of the box, activate, and deploy into the field. So very little, if any, configuration required to get that data flowing and then maximize the time to turn around on that data for your business. So look, we've got a bit of a range of products, but fundamentally there are some target markets that make the most sense when it comes to satellite communications in particular, and the ability to drop in a solution, you know, almost anywhere on the planet without worrying about how that data will find its way back to the cloud platform or find its way back into the hands of your people is of significant value when it comes to the rate of deployment of these solutions. So can I advance, or how do I click through on the next slides and these sorts of things? And I don't think I've presented most.
Just say next.
Okay, sure. Yeah, all right, let's go next and dive into the first use case there. So one of the most common use cases is arguably water resource monitoring. Now, it's a pretty scarce resource and becoming more scarce if you think about the fact that around only 1% of the water on the planet is drinkable water. Water on the planet is drinkable and accessible. So pretty risky resource given our necessity for it. The other side of this, of course, is dairy farming, livestock environments, and these animals drink an awfully large amount of water. A dairy cow can consume the equivalent of 50 gallons of fresh water a day. The average dairy operation of around 2,000 cows will utilize around 100,000 gallons of water a day. This is a phenomenal amount of water if you're having to pull that from a bore or a dam, or capture from other sort of tributaries or lakes or things. So understanding the status of that resource as it pertains to your operation or your ranch or your farm is pretty critical. But often the location that water is captured, stored, monitored is geographically difficult to access, and so keeping an eye on the status of that resource can be complex or expensive to do. And so that's where satellite really prevails, and dropping in a solution that can keep an eye on the level of water in a tank or the amount of water in a bore. You can drop these sensors down a borehole. It gives the farmer the peace of mind that actually the supply of fresh drinking water to the stock at that area of the land is readily available. Also mitigating the risk of emptying a tank as a result of a leak, or monitoring a river or a stream if that were to dry up. So lots of different use cases there, and it is a difficult one to manage when you've got very large properties. So yeah, next slide, Sue. So with the ModuSense water level monitoring solution, this really is a drop-in solution. It's satellite connected and on the Swarm network, which presents a very low cost of connectivity. The Swarm network is designed specifically for IoT connected devices, and there's literally no configuration. You drop the device in, and the data will start to flow. Back on the dashboard side, of course, you need to specify what full looks like, so whether the tank is 2 meters deep or 10 meters deep. That's about the only configuration you really need to care about. And then you can set alerts. So you can set an alert saying, let me know when the tank is down to 50% or 20%, or analyzing the trends, so understanding whether there's going to be an event in the future that you should be concerned about, such as if your consumption rate means that you're going to run out of water in 14 days and it's going to take you at least 14 days to solve the problem, then that would be a good alert level to put on the system as well. Being satellite connected and being a sensor that you drop into the tank or the river or the borehole, it's a very uniform solution. The outcomes here are common across all of the resource monitoring characteristics when it pertains to water. So you can drop these sensors into a borehole up to 200 meters deep. You can put, obviously you need to buy the sensor with the cable that long, but fundamentally the solution doesn't change. Or you could drop that sensor into a small tank, couple of meters deep, or a large tank, and the solution works exactly the same way. There are additional enhancement options when it comes to dropping in this solution. One of them is the fact that the gateway has 2 ports, 2 independent sensor ports, which means that you can plug a second sensor in and the data will simply flow off that second port automatically as well, which means if you have 2 tanks side by side and they're not connected in any way, and you simply want to monitor the level in each of them discreetly, then simply attach a second sensor and drop it into the second tank, and that data will flow. The other thing is these gateways can have additional sensors added to them, which turns them into more elaborate solutions. And we'll come to that later in the presentation, but the idea of adding to the solution not just water level monitoring, but also could be soil moisture, it could be ambient weather conditions. There are a lot of different solution sets that can be made up to suit your requirements there. And downstream of that as well, and I will touch on this today, you can also have Bluetooth connected sensor nodes, which can be within a couple of 100 meters of the main gateway, which means you can have up to 32 monitoring devices within range of a single gateway. So 32 tanks, or maybe a few tanks and a few soil moisture sensors and a few other things. So it's a real ecosystem of capability that does extend beyond simple water level monitoring. Next slide there, Sue. So the product itself, very simple. It's a solar-powered gateway ready to deploy, and the sensor, again, take it out of the box and plug it in and drop it into the environment. So as mentioned, it's a dual port solution. Both of these ports are RS485, which is a industrial, it's a robust industrial standard for digital communications from the sensor, which means that you're not going to risk sort of interference and other kind of conditions on the cable. It's a lot more robust than some other protocols. The solution includes, when you buy the solution off the shelf, it includes the data plan and the dashboards and everything that you need for the first 12 months. So, the price point that you pay, there's no other hidden costs or no other granular fees throughout the year for that first 12 months. The device is Bluetooth as well, as I mentioned. Now, the Bluetooth connection on the device is used both for accessing the device from your mobile phone, but also if you have downstream devices that are connecting over Bluetooth, such as a sensor node, touched on that just briefly before, but also we have other sensor devices that are connected over Bluetooth, and my second use case today will touch on that in more detail. Connecting to it, just touching on that capability to connect to the device from your mobile phone. This allows you, when you're doing an installation, to actually validate the data coming off the sensor before you leave the location. Now, if we bear in mind that the typical implementation here is a remote, difficult to get to, expensive to get to location, this means, and therefore satellite is important from a data collection point of view, but it also means you probably don't want to go back, certainly not very often. And so before you leave the site, understanding that the sensor is installed properly and plugged in correctly, and that it's measuring 1 meters or 2 meters is important. And so we provide the mobile phone interface to allow you to validate the data directly from the gateway without having to wait for a satellite transmission. So 12-watt solar panel recharges pretty quickly, particularly in this solution. The water level sensor does not use much power, and so overnight when it's dark, the battery will drain a little bit, probably 5%, and then as soon as the sun comes out, it's immediately charged again. So really doesn't take long to recharge, and it's a good size 6 amp hour battery built into the product. So again, nothing external, nothing else for you to worry about having to change or maintain. Next slide there, Sue. So the gateway itself, we won't stick around on this slide too long. It's basically, this is the gateway that the sensor plugs into, and this is a common component throughout all of the ModuSense solutions. The gateway is core. It's what we plug into the gateway that turns it into a more comprehensive solution. So next slide. The sensor node looks very similar, and it's actually based on the same platform. So we keep these things common, makes it easy for users to understand how to operate and how to manage the device, also the assembly and the fitment, how to bolt these things to poles and fence posts and so forth. Now the sensor node behaves much the same way. It still has 2 ports. You can plug 2 sensors in. It still has Bluetooth, so you can still have additional sensors nearby, but it does not have any kind of upstream carrier capability. So there's no satellite connection here or cellular connection here. So the way that the data gets back is over Bluetooth. So these devices will transmit their information that they've collected upstream to a gateway, and the gateway is responsible for then transmitting that data over the swarm network back to the ModuSense data portal. So this just gives you that hub and spoke kind of distribution within an installation that is larger than a single tank or a single river or borehole. Next slide, Sue. I want to make sure we've got time for Q&A today. I'll keep an eye on the clock. So another really interesting use case, this one's got a lot more sort of breadth to it than water level monitoring, is environmental conditions. Now, the use case I'm talking about here today is sort of geotech monitoring of landslides and slips and roadway infrastructure, or sort of roading corridors as we call them. And it's pretty important in remote locations where the road may not be used very often, and maybe it's an interstate highway or something, and you've got 3 hours to civilization. You don't want to get there and find out you can't get through. So monitoring vulnerable areas of infrastructure is pretty key to maintaining and upholding the ability for transit on highways. And we're seeing an increased demand for monitoring of this because again, it's expensive to send people in poor conditions. It's risky to send people, and arguably it's in poor conditions when you need to send people. So understanding and management, using a management by exception approach, so understanding the conditions of the environment before you send anybody, or understanding whether you even need to send out anybody, is pretty key. So again, the problem here is very similar to water level monitoring in remote locations. It's geographically remote, it's expensive to visit, these places are difficult to access, and in today's world, economically, when you're needing to do more with less, that means probably trying to send one person, not 2, and so we end up in these lone worker situations, and there's high risk sending lone workers into remote locations, particularly in bad weather. So a lot of risks associated with actually achieving these outcomes. Again, no cellular coverage means satellite's important. No cellular coverage increases the risk for lone worker as well. So a lot of sort of competing factors there. Yeah, next slide, Sue. The solution here with ModuSense, I'm just going to play a quick video to give you a real sense of how far you have to go to monitor these environments as a human, and why putting effectively call them robots, but the telemetry gathering gateways into the field is critical. So we'll just play this. This is a location we do have some equipment called the Gates of Haas, and it's down in that valley there. If we zoom out and spin around, we're going to see the scale of the mountains around that valley. It's pretty phenomenal, and you've got to think, well, how do you get any kind of radio signal out of a valley that is also obscured by surrounding mountains pretty much in every direction? So quite a tricky piece of country to get to. It's about a 4-hour drive from civilization each way, and yeah, no one really wants to go there unless there's a fundamental need to do so. So right there in the middle of all of those mountains. So this is New Zealand, largely upside down, but that's where I am. And so it's a good example of where this equipment is providing high value to the end user and to the customers involved. So just to put that into perspective for you. Next slide, Sue. So this is on the ground, boots on the ground here in the Gates of Haast, and we've got this weather station sort of set up here with air quality and rain bucket and a few other things going on, monitoring, river levels and slip levels within the hillside. A lot of monitoring going on in this environment to preclude the need to send humans all the way out there, sometimes for no good reason at all. Although in this photo you can see there's a bit of roadworks going on, so there's people around anyway. So again, designed specifically for IoT, no configuration requirement, simply concrete in the post, assemble the equipment, and double check the sensor readings, and then you can leave the location. So one thing that the swarm network does in these environments that some other satellite networks can't do or doesn't do is these satellites are orbiting the globe in a polar orbit fashion, which means the satellites are flying North Pole to South Pole, all day long. It's about an hour and a half round trip for one of these satellites, which means they'll go overhead every sort of hour and a half, 90 to 100 minutes, which means that they're actually flying above you, whereas geostationary satellites, which are quite common for providers like Inmarsat and a few others, they're based typically off the equator, which means they're on the horizon, and they don't move. Which means if they're obscured by any of these mountains that are surrounding this location, you won't get a signal out to that satellite. So satellites that fly overhead, although they're not there all the time, they actually provide a good view of the planet from all sorts of different angles that you don't get from a geostationary network. So there is a benefit there. Yeah, even if you have to wait an hour for the satellite, at least you can get the data out from that location that would otherwise be impossible. So it's a good outcome there. Next slide, Sue. So as mentioned, monitoring slips. Now this is an attenuation cage where this is a pretty simple one, but where they install these cages down the side of the hillside to stop rockfall and subsidence and these sorts of things. You can install the sensor. We have a sensor called a high resolution tilt sensor. You can install these on the cage themselves, which means that if the hillside moves or any rocks fall and get caught by the attenuation cage, then that will affect the angle that the cage is sitting at, and the tilt sensor will be able to report a change in inclination, and you can see that on your dashboard and take the necessary action. Also, we have extensometer options in the geotech space, which can be buried in the soil or grouted into rock or bolted into rock. So depending on the environment, the extensometer will give you, again, very, very high resolution change within that environment. So if you can see the soil is moving and it may only be 0.5 millimeter a day, but it's constant, then you can predict the likelihood of the hillside collapsing in the next rainfall, or maybe the next storm, or when a tree comes down or something. So monitoring these environments and understanding what good looks like, so that when there's a change, you can appreciate that may no longer look the way you left it. Next slide, Sue. We'll dive into the actual product that does this. This is the ModuSense Bluetail. This is a Bluetooth device. It's in an extremely ruggedized enclosure. It's a metal anodized enclosure there, and it can handle being dropped. It can handle being pretty much driven over rock falls. That they even use these sometimes in mining, so they can withstand a blast. Obviously not a direct blast, but nearby. So a pretty strong device, and you can bolt that or epoxy it or simply cable tie it if you wish to an environment, and then you'll get the data coming off that at 0.001 arc degrees of resolution, which means a very, very sensitive device. So it can be used to monitor any change in that environment and very low power. Has 2 internal 3.3 volt lithium D-cell batteries, and it'll last at least 4 years, sort of beaconing the angle of the inclination change once per hour. So that can be increased or decreased, of course, in terms of reading frequencies, but that's the general rule of thumb there. Now, these devices are also Bluetooth 5 long range, which means they will transmit the information back to the ModuSense gateway. Normally 200 meters or so is quite good. There are a lot of factors that can affect that. You may get 300 or 400 meters in some situations, or you may get only sort of 100 or 150 meters in some situations. It depends on where that antenna is pointing and whether there's any trees or hillsides in the way. Essentially a line of sight between the device and the gateway. But the customers that we've implemented this with have put a large number of these across the hillside, so they're sort of mapping almost like a heat map of the hillside, so we can sort of see which parts of the hillsides are moving and what risk that represents. So next slide, Sue. Earlier in the presentation, I touched on the fact that the gateway is the common core component, but it can be turned into other products. Now, if you just want the gateway to sit there and collect data and transmit it over satellite, that's great. You can have nearby Bluetooth devices. But if you want it to do more, then we have a few other ready to deploy solutions, and one of them is the weather station. This is a sort of a graphic of that here, with a wind speed, wind direction sensor on top, and a temperature, humidity, and barometric pressure sensor internally, focusing more on ambient conditions. This can be implemented in place of the gateway, which means that you can still monitor your tilt sensors or your extensometers or your river level or your tank level, and include these environmental ambient condition data points as well. So just an example of the evolution of the product into other options. And next slide, Sue. The other one that's very common is air quality. So again, temperature, humidity, we have wind speed, wind direction on top there, and we've got the particulate matter sensor, the PM2.5 and the PM10 sensor monitoring the particles in the air. Some interesting use cases come out of this one, not only purely just monitoring the quality of the air and the environment, but we've had people install these things and get early warning of sort of smoke coming from a forest fire if the wind is in the right direction, or if they're a beekeeper and they want to know what the air quality is doing around the apiary, then that's another interesting use case. So air quality is not always reserved to cities and understanding the breathing conditions for humans, but it can be used in many different ways. So we see some interesting use cases coming off that as well. Next slide. So bringing that all together, ultimately the reason for deploying these devices and utilizing satellite networks to get this data out of remote locations is the data itself. So that is the outcome, that is the whole purpose. So bringing that all together in a single pane of glass, providing you, your team, your users with easy to use and easy to access dashboards to visualize the information coming from the field, understanding trends, setting alerts, setting notifications based on under or over thresholds or trends, and using those insights to drive operational change in your business. And that's where you can arguably get ahead of your competitors and make the changes in your business that are going to allow you to do more with less, to use that cliche again, or ultimately just improve the bottom line through mitigating risk. Another interesting one I will just touch on that comes back to that infrastructure monitoring is bridges. So I talked about rockfall and landslides and these sorts of things, but bridges is one that's come up a little bit recently. There's more than 600,000 bridges in the USA, and as I understand it, 46,000 of those you probably wouldn't want to drive across from a structural integrity point of view. So anyone on the call today that's looking for a target market, is 46,000 reasons to go and put some highly accurate tilt sensors on bridges, let alone the other 600,000 that probably could do with a little bit of repair as well. So some decent sized markets out there for infrastructure monitoring and mitigating risk. So ultimately this is about realizing the value of the data that's been collected in the field, and making sure you can get that information back in the hands of your users, where it can be turned into value for the organization. So these dashboards, just to touch on it a little bit, out of the box, obviously we have the air quality, the weather station, the water level monitoring, a few other solutions there, and we have corresponding dashboards that are ready to use. There's literally no software to write, no configuration requirements. Log on, the data will flow automatically from these devices, and it will appear on the dashboard, and you can start benefiting from those trends and the analysis that takes place. If, however, your organization does want to do something a little more bespoke, you want to bring in another data set, or you want to do some trend analysis in another way, then by all means get in touch. We can customize these dashboards and implement analytics algorithms and processing to achieve those outcomes for you. And the whole thing can be branded. It's all white label enabled, which means that you can upload your own branding and make it your own. So. Next slide there, Sue.
All right, Bruce, I'll take over from here.
Thanks, Tony.
Hi, everybody. This is Tony Battaglia, head of sales at FreeWave. Big thank you to Bruce for that. I know a lot of folks have been waiting quite a while to jump on and learn more, so we certainly appreciate Bruce and the ModuSense team. A few things I want to touch on before addressing questions. If you guys do have any questions, please put them in the question box, and we'll get them addressed here in a minute. We have a few that came through already. But we've certainly come across a lot of new interesting use cases and proof of concept sense engaging in this joint venture, and we'd certainly love to hear more from everybody on this call. If there's any interest, if there are any opportunities, or you just simply want to learn more and get a proof of concept going, please reach out to us. We're incredibly interested and eager to see this really come together, and we do have inventory out there available, both in-house in Boulder and in the channel as well, with relatively low lead times. So, Sue, if you get to the next slide. Before addressing the questions, we've gotten several questions since engaging in this joint venture on really what does it mean, what is the scope of it, and how does that translate? What does it mean for FreeWave? What does it mean for FreeWave's customers, and what does it mean for FreeWave's partners? So given that we have a lot of that audience on this call today, I hope the session gave you a good idea and a good view into what it does mean today. But outside of what Bruce just highlighted here, it's really going to help accelerate our development. So in addition to what we reviewed here, ModuSense really acts as an innovation center in addition to the equipment provider. So with Bruce and his team of very, very talented individuals, they were basically going to help fuel FreeWave's timeframe to market, fuel some of our design elements, and fuel really the direction that we're going to be headed in how we get these products out to our partners, out to our customers, and into the market. So this can actually be seen already in our Fusion satellite products. Those of you who have had some experience with those since our launch earlier this year, not only did it help provide the satellite communications via Swarm, but also some of the data routing mechanisms that are currently being rolled out today. So that's just one very small example of where we expect this partnership to grow over time. And even in less than a year in, we're already seeing quite a bit of collaboration going on. So it's all very good. But with that, let's address some questions. We had a few come in already. So again, if you guys do have any questions, please get them in the question box. I'm trying to get the window open on my end so I can get the full view. So the first question is, we talk a lot about how our accessing remote data, which is something we're all pretty familiar with. Will this device, will this satellite system work effectively anywhere, Bruce?
Yeah, it's a good question. The answer, the answer is fundamentally yes from a technology point of view. These satellites orbit the globe in a polar fashion, as I say, every 90 minutes, and there's 150 plus of these things up there now, and more being launched as we speak over the next couple of months. So yes, technically, the only caveat there is that much like you may have heard in the news, Starlink having some trouble getting into India and Pakistan recently, you required commercial landing rights in each country of operation. Now, Swarm have worked very, very hard on achieving that, and they've got a huge list of countries already approved. Pretty much all of the ones that we currently have conversations going in, so that's good. But they're adding more all the time, and we work very closely with Swarm on understanding that roadmap and in what quarter of each of 2022 we're expecting to see more countries submitted. So again, just engage with us, the FreeWave team and the ModuSense team. If you have opportunities in a country that we're not sure if there is landing rights yet, then landing for data, not the satellite itself, then get in touch, because we have access to that information and we can follow up with Swarm on progress there as well.
Thank you, Bruce. Another question, this one's a little bit longer, but it actually does touch on a lot of the questions that we've come across already, so bear with me when I get through this one. One of the main problems in maintenance is the action of environmental factors like chemicals, dust, humidity, temperature, contaminants, and that affects the equipment, and the effect is only evident after a failure. So industrial environmental monitors would be useful for maintenance planning as well as for plant personnel health and safety. How can a solution of this type, could it be configured and integrated to gather information in a consistent way, not only to have alarms, but also identify environmental patterns? For example, problems in environment caused by plant problems or external environment changes. How can this information be integrated with SCADA records to analyze information in a global way?
Great. So I picked a couple of questions out of that phrasing. Thanks, Tony. So one of them is ultimately around the ability to sense different environmental factors. So being RS485, Modbus compatible or natively supported in the gateway means that we can plug in a huge array of sensors that are available on the market, whether that's methane or ozone, sulfur dioxide, carbon monoxide. We have all of these sensors in the portfolio, and if you require sensing for a gas or a particulate matter that we don't have, then we can go and find that sensor for you. So on the sensing side, pretty straightforward. It comes down to, is there a sensor available? Can we power it? And then, how do we talk to it? So ultimately, the RS485 interface becomes the question there. On the other part of your question was really bringing that all together and maybe linking that out to SCADA systems and so forth. The data broker, the routing engine within the ModuSense platform. Yes, we have dashboards and analytics and visualizations that you can consume, but you don't have to. The data routing engine sort of within that stream of pipeline of your data means that we can configure, or you can configure actually yourself within the self-service tools, endpoints for that data to push out to. So whether that's webhooks or MQTT or other kind of protocols, you can have that data configured to go out to some other third-party system in real time. So you don't have to batch process this or come and get the data. It can be pushed to you. So a lot of options there to make use of the data. What we obviously have the platforms for collection and the array of sensors to do the job. Plenty of options on the other side as well. And for those who are interested, that's ultimately where the name ModuSense comes from. This is a modular architecture. It's modular both on the hardware side, it's also modular on the software and the data outcomes side of things as well.
All right. Stuff. Lots more questions to cover too. So in the event that we don't get to all these questions, we'll certainly follow up directly with you guys. But with that said, I think we have a bit of time here still, so let's keep getting through these. I understand the satellite service is included, so for what time frame and what is the cost?
Sure. So when you buy the product, the first 12 months of everything is included. So that really speaks to the ready to deploy side of it. We don't want you to have to come back and then activate a data plan or activate software or any other kind of subscription. So the first 12 months is included in the solution cost, and then you're renewing that every year. So at the end of that 12-month period, there's an auto notification and then a renewal process to renew that data plan. And any corresponding features that you may also be consuming. So dashboards or analytics included in that package as well. So the cost of that depends on what it is you're consuming. So if it's just the Swarm data plan, or if it's a full suite including the data routing and the dashboards, then yeah, that's the renewal of that component. Does that answer your question, Tony? Sorry.
I believe so. I believe so. And okay.
I will just interject on that. Just to follow up though, is that the Swarm data plan includes 750 messages per calendar month for the year. That can be increased. That's enough. That's enough sort of data volume to collect and report 15-minute data points off any of our ready-to-deploy solutions. And if you need to increase that, you want to come down to 5 minutes or 1 minute data points, or you want to increase the number of devices being aggregated by the gateway, then you may need to increase that data plan. And the data plans simply stack. So it comes with one data plan. If you need to double the amount of data, then you simply add on a data plan, and that takes you from 750 messages a month to 1,500. And you can do that 4 times. So you can go up to 3,000 messages per month, which really gets your data volume up there in terms of the number of devices or the number of data points being collected.
Gotcha. All right, let's keep moving through. Thanks, Bruce. Who do I contact for technical support? Who at FreeWave do we contact for technical support? So I will address that one. Just the standard support team, Greg, Corey, and team that you guys are all familiar with. We are well equipped to support this product just as any other FreeWave product. So they are actively getting up to speed, going through training on this, and I would say, though it's 2 separate organizations through this joint venture, treated as a FreeWave product, we will support this the same way, just as well as we support any other product under the FreeWave brand. And moving down, the connections that we highlighted are only via satellite. Can this be connected through other alternatives like LTE, wireless point-to-point, multi-point microwave systems?
Sure, I can grab that. So again, being modular, we like to certainly sing the praises of being modular. We can accommodate alternate carriers, alternate upstream. So satellite, we have a number of carriers that we currently support, and then we have cellular as well. So LTE, CAT-M1. So that's the IoT, CAT-M1 and NB IoT modules that we can put in there as well. But also, for those who are familiar, FreeWave have the Z9 radio suite, which means that we can augment these solutions with pre-existing FreeWave product to make use of these long-range radio capabilities as well. So really, the essence here is bring your use case and your requirement, your needs to the FreeWave sales team, and let's have a conversation about the best technology to solve that problem. And it might be that you've got 20 miles from point to point, and you don't want to put in 2 devices, so you want to use a radio link, or you've got a hub and spoke scenario, but the range is quite far. Then let's have a chat about the different technology options, because there's plenty of them, and being modular, we can certainly dovetail this stuff in there, all the way down to an Ethernet port. And we can take the Swarm modem out and plug in an Ethernet module, and you can plug this thing into an Ethernet network. We've done that before as well. So a lot of modular options there with the way that this product is architected.
Very good. And a question in the same vein, that's on the back end, the communication end, but on the actual sensing end, a question on, can I use or bring my own sensor? Is there a list of third-party sensors that have been approved to work with these devices?
Sure. So being RS485, we have to know a little bit about the device. So first of all, how much power does it draw? Because this is a solar-powered battery backup gateway, which means that power is certainly something that we keep a close eye on. And there's options there, of course. We can run larger batteries, and we can run external batteries, and we can accommodate slightly longer run times. But the first thing about these sensors is how much power do they draw? So we have a range of sensors that we have pre-approved, and they exist in the firmware today. You can simply connect to the gateway, using the mobile app, and you can configure from a drop list, very easy to use. You can configure from a drop list what you have plugged into port 1 and what you have plugged into port 2, and how often you want to take a reading from that. So very, very easy for an end user to simply configure the device for that. Getting a new sensor into the firmware so that you can make use of those simple tools requires that you engage with us and our engineering team around the inclusion of that sensor, which normally requires the spec sheet be sent through. We'll validate the spec sheet in terms of power requirements, how long it needs to be powered on for, therefore overall power consumption per day, per week, per month. And then for complete implementation, we need, in most cases, not all, but in most cases, we like to validate with a real sensor. So getting us a first article of that sensor to then test and put through the validation program, and then it becomes baked into the firmware, and you can go ahead and deploy that in the field yourself.
Very good. Thank you, Bruce. A few more. I think we can get these addressed in time. For a Modbus device with 15 to 20 Modbus registers, what's the limiting factor for adding more of those devices?
So the reason we have two ports, so let's think about the architecture of the gateway. It's two RS485 ports. Now you might think, initially you might think, well, that means I can plug two devices in. Yes, that's true, but it's not limited to two. These ports are completely independent. Each of these ports is a separate Modbus and a separate power supply. So they're not in any way electrically attached at the Modbus level, which means that you could plug a device into port 1 with an ID of 1, because it's a bus, everything needs an ID, and you could plug a device into port 2 with an ID of 1, and they won't conflict. Now, if you can plug more devices in, so long as they have a different unique ID on that bus. The real thing to consider here, and this comes back to the fact that the gateway is a solar-powered, battery-backed up device, is that as soon as we power on that port to take readings, every device on that port will power up. So we need to consider the overall power consumption of the port. And if you've got water level sensors, these things only draw around 7 to 10 milliamps. So when you power them on, they're not drawing that many. We could probably put easily, 6 or 7 or 8 of these things on a port, which means you could have 16 tanks hanging off one gateway nominally, but you'd need to first of all go in and readdress each of those sensors so that they each had a unique address. And from there, the registers, that really comes down to data volume. The more data points you're pulling off an RS485 device, the more data points, so the more bytes of code, the more bytes of data per reading that has to be packaged up and transmitted over satellite. And so we only have 192 bytes per message on the satellite network. So, if we're collecting more than 192 bytes of data every hour, then we're going to need to increase that data plan from 1 to 2 or 3, 4 data plans to accommodate that. We can send multiple packets per satellite pass. I think the most I've ever seen was 33. I know that you can send more, but the most I've seen on the fleet was 33 in a single pass. So obviously just talking to that satellite the whole time it flew over, getting 33 messages out in one go. So there's plenty of bandwidth there to get this messaging out. Obviously there's just a slight increase in cost to do so.
All right. Time for about one more here. Can you read and write via ModuSense?
So read and write, I'm going to take that to mean command and control. In terms of if you say you want to turn off a relay or close a valve on an irrigation pipe or something. So the short answer is yes. Bear in mind that this is a satellite network and it requires the satellite to fly overhead. So let's think about the data flow and the latencies involved. You've taken a reading, it's 9 a.m., you've taken a reading and the tank level is 50%. In 9:15, it's 40%. 9:30, it's 20%. That's a bad trend. And then that data gets transmitted on the next hour. By the time you get that information, the tank's empty. So that's probably bad in terms of the latency. If it's a massive leak, you're not going to have a command and control round trip capability with Swarm, because it'll take you several hours to get the data and then get a packet of information back. So command and control in anything mission critical, you really want to be using either a geostationary network like Inmarsat, where the latency is 15 seconds in either direction, or cellular. Or long-range radio with the FreeWave Z9. So lots of options there, but the swarm network is whilst you can send messages to the device, we typically recommend that customers take the approach of utilizing the downstream message construct to update a configuration. And to put that into context, you can put some intelligence on this device, or we can for you through our engineering program. You could say, if the data, or if the tank level changes by more than 20% in an hour, then close the valve, for example. So you can put that intelligence on the device, which means that it's doing its own interpretation of the last 4 readings and taking action based on that. So you're not waiting for a round trip to do the command and control activity. You're actually pushing a configuration to the device which says, 20% I want to close the valve, or 50% I want to close the valve. So that would be the use case, rather than actually a discrete sort of intent being pushed over satellite, unless you change, as I say, the carrier to cellular or Inmarsat, which are options.
All right. Thank you much, Bruce. Well, that's what we have time for today, so we'll go ahead and wrap this up. Thank you, everybody, for taking the time to join us. If you have any questions, please reach out direct. We're happy to discuss, happy to help you through. And as we mentioned, very curious to come across new and exciting use cases. So thanks again, Bruce, for joining us. And yeah, great session. Take care, everybody.
My pleasure. Thanks, everybody.
Thank you, everyone. And as I mentioned in the beginning, this session is being recorded, and you will receive an email with the link to the recorded version. Thanks, Bruce. Thanks, Tony. And thanks, everyone, for joining.